My name is Motaz, and to complete this project, I will be using a liquid that I have been drinking for the past 12 years plus, and that is milk. You see, I have this wonderful habit of whenever I wake up in the morning, I actually drink a cup of milk with grinded coffee. And I heat the cup of milk, as you see here, for a couple of minutes. And that causes it to actually develop a skin-like layer on top of the liquid or on top of the milk that I actually end up removing most of the time. Now, why am I mentioning this? Because today I will be explaining surface tension, which is also described and seen as a skin-like layer on top of liquids due to their properties. Okay, let's use this drawing board here for a minute. Surface tension is the tension caused by different molecules that are aiming at minimizing surface area because it is cost expensive to have a large surface area. So less surface area equals more energy saved. So this reaction of molecules actually causes a skin-like layer to form on the surface of a liquid that are very tightly bonded. That is called surface tension. And it can actually hold larger density items. Let's explain further. Water actually has a very high surface tension value. Imagine that the water here is just like the water in the diagram. The water molecules in the middle are actually interacting with all the water molecules around them. But the ones on the surface are affected by surface tension and actually have a force of pulling downward and centerward that are interacting in these directions with the rest of the water molecules. And this is seen when a droplet of water drops. It actually has a center force pulling it together and doesn't spread all over. So the droplet stays just like the picture that you see on the screen. Okay, let's use these two experiments to visualize what happens when surface tension is affected. Let's first start with this one on the left. Now what I have here in the cup, in the plate, is actually milk and peppers. And I have here dishwater soap. I'm simply going to take one of them out, if I can. And you're going to see, right when I drop it, what's going to happen to all the peppers. They all move to one side because of the droplets coming down in the milk and actually affecting the surface tension by interacting with the molecules. Now, if I put it here, there's not much of an effect because the dishwater soap is on this side and is actually already affecting the surface tension, and it broke it of the milk. Now this area is done. Next, we're going to be using the milk and the food coloring droplets. So I'm just going to go ahead and drop a couple
droplets in the center of different colors. As you can see here, I'm going to shake it just a bit so that all these droplets can just stay in the center. And we're going to use dishwater soap to see what happens as a visual. So this looks really nice now. I'm actually going to take this out and wipe it on the side.
And then now just watch what happens when I put this inside. You can see how it's moving from the center outward, affected by the dishwater soap as a beautiful visualization of how all the surface area is affected. Now, to explain what actually is happening here, the milk is interacting with the dishwater soap and is coming in from all directions to interact with it. And the movement of the food coloring is actually helping us realize and see into visualization of how the surface tension is affected on the milk. Okay, so here I have a table that shows a bunch of different surface tension values for common liquids. And I want to make a note that water at 20 degrees Celsius and water at 100 degrees Celsius, we notice that it dropped. That's because when temperature rises, surface tension decreases. Here we have example problems for the calculation of surface tension. We see that the force is pulling a film of fluid one way, while surface tension is acting the other in order to minimize the surface area, just like we mentioned earlier. To end off, I have here some important implications of surface tension. For example, it's important understanding liquid behaviors. They use it in hospitals with examinations and tests. It's used in extraction of oil. It's used in cleaning agents of products in the terms of production, and so much more. Our lives will be better by understanding these concepts as a whole and of all these phenomena. Thank you for listening, and I hope this was beneficial.